Hello everybody, welcome or welcome back to my channel. In the previous video we saw corrosion control techniques. In the first one we saw protective coating, where we decided on doing with metal coating by galvanization and tinning. Then we did surface conversion coating by anodization, where the anode was positive and the cathode was negative, and the anode was made aluminium. Now next one is cathodic protection. Before, I want to make a small change. Instead of your impressed voltage, I wanted to be impressed current. That change, my bad. I had made that mistake everywhere. I had to change it. I will make it impressed current. Okay, everywhere. Here also impressed current. Okay, that one thing I wanted to change. Now let's continue. So the next topic is cathodic protection. The name only is there. So basically trying to protect the cathode here. Okay, that's the main intention. The first one is sacrificial anode. So here what we are doing is, I'll take an example. It's not a very effective method. A cathode is there. We want to protect it because our main intention is to protect this cathode. Cathode is going to be the metal which we want to protect. That is going to become the cathode, because cathode will not undergo oxidation, it will not undergo corrosion. So we will connect an anode to it. This anode will undergo oxidation. This anode will undergo corrosion. So this is going to protect this cathode from undergoing oxidation and corrosion. Now because this anode is there, right? It's going to get consumed. This is going to get corroded. So you have to replace this anode again and again, so that this can get oxidized, this can get corroded, but it should protect this one. It should protect the cathode. So we attach anode to the cathode. By differential method corrosion also we have studied types of corrosion. That method also you can relate to this. So anode is going to undergo oxidation, it's going to undergo corrosion. Cathode is going to remain unaffected. Anode undergoes corrosion, which protects the cathode. It's not very effective. Example to this is steel bar, or zinc or magnesium bar is attached to steel bar. The zinc or magnesium bar in ships, especially if the ship is made of steel, here you can see that magnesium bars like this, it can be attached to the ship's zinc or magnesium bar. That's also one of the example. And now that is the basically what we studied sacrificial anode. We are connecting an anode to a metal, connecting an anode metal like zinc with respect to the metal to be protected like an iron from corrosion. Anodic metal sacrifices itself, undergoes corrosion, oxidation. So to protect the base metal, we have to replace it frequently. That's what I've told. In water tank, pipeline, also this is used. Mainly it's used in waterline pipeline. What I told in marine ships, that is mostly used in impressed current. This also, okay, but mainly remember in waterline pipeline it's used. Waterline pipeline I will write here. This I am not very sure if it's used or not. So just in safer side, I'll write waterline pipeline, because if application question comes, it should not be confusing. Waterline pipeline you can remember. The next one is impressed current. Now in this only two topics. One is anodization and one is this impressed current, where the anode is going to act positive and cathode is going to act negative. Little bit comparison I'll give. In anodization, what was the thing is, we wanted the anode itself to be protected, correct, but we want anode also to undergo oxidation. So what did we do? Even though we made anode positive, we made this the aluminium, that is the anode, okay, and cathode, which was negative, we made that cathode the inert material, stainless steel, correct. In this impressed current, what are we going to do is, here also anode is positive, cathode is negative, okay, but we want here the cathode to be protected. Suppose ship example I am taking, right? Ship is made of iron. Just example, iron. This is going to be the inert material. This is here is inert. This is inert here. That's why it's confusing. But both here, this is anode only and this is cathode. Here also this is anode, this is cathode. But here the metal is given to the anode. Here the metal is given to the cathode, because one cathode will be protected here. So now what is going to happen is that DC supply is given, right? That is going to supply so many multiple continuous supply of electrons to the cathode. So this never has to lose electrons. This will not have to lose electrons. That is the idea over here. So when we connect the metal to DC source, electron flows towards the metal, that is the cathode. So being cathode, no corrosion will happen there, and the reverse current towards the metal is known as corrosion current. And in this method, electrons are supplied from a direct current source applying a DC larger than corrosion current. I'll give you a simpler version. So basically, electron is supplied from DC source. The metal is connected to negative terminal of DC source. That's what this is. So it makes it behave like a cathode. Now potential greater than the potential of the anodic potential. Basically, potential greater than the anodic potential is applied in reverse direction. A potential greater than the anodic potential is applied in the reverse direction to prevent anodic reaction. So entire metal behaves as a cathode. So in cathode we know no oxidation, no corrosion. So the positive terminal is an inert material which is connected here. This example you can say marine. In marine this is used. Positive terminal is the inert material and the negative terminal is the one which has to be protected. Like example steel. For example ships, in case of ships. I've got a simple logic here because this topic was extremely confusing for me to understand as well. So suppose take an example of ship. That's the metal to be protected. That we don't want the ship to get corroded, obviously. That is going to be the cathode. Any inert electrode you can take, that's going to be the anode, positive terminal. So when DC source supplies electrons to the cathode, it is actually supplying electrons directly to the ship. Logic, just for you to understand. When the DC source supplies electrons to the cathode, it is supplying electrons to the ship. Makes sense. The ship is a thing that would normally corrode. Technically speaking, don't take about cathode not going to get corroded. Technically, why are we making the ship as a cathode? Because we don't want it to corrode. Technically, the ship was the one which is normally going to corrode. Now, if the battery was not there, here we are using DC supply impressed current, yes. But if battery would not be there, the ship would lose electrons. Then iron would become Fe, is going to become Fe2 plus 2 electrons. Then corrosion would occur. But with the battery keeps supplying electrons to the ship. So the ship remains the cathode. Iron atoms do not oxidize. Therefore, the ship does not corrode. And then why do we need anode? The anode is not being protected here. The anode is an inert material, correct? Its job is simply to complete the electrical circuit. Oxidation reactions occur at the anode instead of the ship. That's why we are using the anode. So basically, don't get confused that cathode anyway corrosion would not occur. Yes, that's exactly why we are making cathode the iron, but iron will undergo corrosion, right? So that's why we are going to supply it with so much electrons that it remains as the cathode, so no oxidation occurs. So that's what I told you. We are going to supply electrons from the DC supply to the cathode in the negative terminal, that is to the metal structure, that is going to behave as the cathode, and the potential greater than the potential of the anodic potential greater than the anodic potential is applied in the reverse direction. So to prevent anodic reaction, all of this you have to kind of learn it by heart. So the entire structure behaves as the cathode. The cathode structure is going to behave as the cathode. So there no corrosion is going to take place. Once again I'll tell you, DC supply supplies electrons to the negative terminal, which is going to be the cathode, where the metal is attached, and that is going to behave as a cathode. Potential greater than the anodic potential is applied in reverse direction to prevent anodic reaction, and the entire metal structure is going to behave as a cathode now. So no corrosion. The positive terminal will have inert material of the anode, and their anode oxidation can happen, but here at least in cathode, where the metal is there, the metal to be protected is there no corrosion will take place. So try to explain this topic in a simpler manner. Hope I've done a good job. So see you in the next one. Until then, bye bye.